Good morning to everyone. This is Devasis Mohanty once again welcoming you to our polynomial chapter discussion. So in this chapter we will get to learn first one, it is our introduction about the polynomial. Second one, we will get to learn how to get the zero of the polynomial. Thirdly, we will get how to show it in the graphical method, otherwise the graphical representation of the polynomial. And the fourth one is relation between the zero and the coefficient of the polynomial. So it means four things we will get to learn in this after the completion of this chapter. And first point, it is our introduction about the polynomial we will get to learn. Second one, it is how to find out the zeros of the polynomial. Then after the graphical representation of a polynomial, and the last one, it is relation between the zero and the coefficient of the polynomial. Understood and not understood? So first point, we will do the discussion about the introduction of the polynomial. So before we need to do the discussion of the polynomial, one of the previous term I want to do the discussion, and the name of that term, it is our algebraic expression. In our standard 7 and in our standard 8 already we have done the discussion what do you mean by algebraic expression, but once again I am repeating what is the definition of algebraic expression. You just have to remember algebraic expression means it is the combination of the constant with the variable. Constant with the variable with the main for mathematical operators, it is called as our algebraic expression. So algebraic expression, it means the variable is there and constant is there, both combined with each other with the main for mathematical operators is called as our algebraic expression. So few of the examples are here. One, it is our 2x. So 2, it is the constant, and x, it is our variable, and here it is the operator, it is our multiplication. Next one, it is our 2 plus x. It is also one of the algebraic expression. Here we got the algebraic expression by the combination of the constant 2 and the variable x with the addition. Then after 2 minus x, 2 it is the constant, x it is the variable, and here the algebraic expression it was formed by the operator minus. Next one, it is 2 by x. So here the operator used, it is our division. And the last one, it is 4x plus 1. So here two operators were used. One, it is our multiplication, and another one, it is our addition. So here it is 4x plus 7 means actually we obtained the algebraic expression by the product of 4 and x, and whatever the product we got by the multiplication of 4 and x, that product we have added with the 7. So for which here both the operators were used. Understood and not understood? So after you are getting the knowledge of the algebraic expression, now we will go towards our definition of our polynomial. Okay, so polynomial, it is very easy. You just have to remember polynomial, it is also algebraic expression. Polynomial is that algebraic expression. Polynomial is that algebraic expression in which the power of the variables are always whole numbers. Polynomial is that algebraic expression. Once again repeating, polynomial is that algebraic expression in which the power of variables are whole always. If the variable used in the algebraic expression having the whole power, it means that algebraic expression we can call it as the polynomial. So few of the examples I have shown it at here. So first one, it is our 2x. Here it is 2x means here it is a single term. Here the polynomial having a single term. So where 2 into x, so 2x means x to the power 1. And here it is 1, it has the whole number. So for which we can call 2x the algebraic expression, it is also one of the polynomial. Another one I am showing, another algebraic expression, it is 3x plus 6y. 3x plus 6y. So 3x means x to the power 1, which is whole, plus 6y, which is in which the y to the power, here it is also 1. So it means both the terms having both the variables, also both the variables, their power it is also whole. So for which it is also called as the polynomial of two variables. Previous one polynomial of one variable, but here it is the polynomial of two variables. And the next one, it is our 5. 5, it is a constant. So constant means no variable is there. So for which 5 means x to the power 0 into x to the power 0. 5 into x to the power 0 constant term means you just have to remember always the variable having the power it is equal to 0. So for which 5 it is also called as our polynomial. Clear? Then after few of the example I am showing, from where you will get the knowledge that few of the examples which algebraic expressions we cannot call as them the polynomial, which are not the polynomial. Okay, few of the example I am showing. So first one, it is a 2 divided by x. So one will say, sir, 2 divided by x, here also x to the power 1. But our formula is whenever the variable it is in the denominator, always you have to convert the denominator variable it into numerator. Then after you just have to check the variable power it is whole or not. If whole, polynomial, otherwise it is not the polynomial. So 2 by x, here in the denominator x having the power it is 1. But whenever I am making it as the numerator, it becomes 2 into x to the power minus 1. So here we are getting the power of the variable it is minus 1. So for which 2 by x it is not a polynomial. Clear? Another example it is 1 divided by root over of x. 1 divided by root over of x. Root over of x means in the exponential form it becomes x to the power 1 by 2. It means 1 divided by x to the power 1 by 2. And our formula is, if the denominator having the variable, we just have to convert the denominator variable it into numerator variable. So whenever I am changing the denominator x it into numerator, it means the sign of the variable it will change. So it means it becomes 1 into x to the power minus 1 by 2. Previously it was plus 1 by 2 in the denominator, but in the numerator it becomes x to the power minus 1 by 2. As minus 1 by 2 it is not a whole number, for which 1 divided by root over of x it is not a polynomial. Ready? Another example I am showing root over of x. Actually root over of x it is already in the numerator numerator side. Root over of x means root over of x divided by 1. So for which x it is in the numerator side. So for which only we have to show that the power of x it is how much. So here x to the root over of x it means x to the power 1 by 2. As 1 by 2 it is not a whole number, for which root over of x it is not a polynomial. Another example I am showing. Here in the example the algebraic expression it is given x to the power 3 by 2. X to the power 3 by 2 plus 4x square. X to the power 3 by 2 plus 4x square. It means it has two terms. So in the first term x having 3 by 2. In the another term x having power it is 2. So it means in the first term the power it is not a whole number because it is 3 by 2. And in the second term here the power it is the whole number. But my formula it was said to you that all the variables should have the power it as the whole number. All the variables should have. But here it is whenever one it is failed, for which we cannot call it as the polynomial. Understood? So now we will do the discussion of the one of the term. That term name it is called as our degree. What do you mean by degree? Remember the definition of the degree. Degree is the highest power of the variables. Degree is the highest power of the variable amongst the term of the polynomial. So degree of a polynomial it is the highest power of the variable amongst the term it is called as our degree. Ready? So few of the example I am showing. So from here you will get the information that the polynomial its degree it will be how much. So one it is 2x. So 2x means here the power it is 1. As it has a single term, so for which 100% its power it will be the greatest one. So its power it is 2 into x means x to the power 1. So for which this polynomial having the degree it is 1. Ready? Another polynomial I am showing you. One it is 2x square plus 3. 2x square plus 3. It has two terms, and in the first term the power of the variable it is 2. But in the second term it is the constant term, means power of the variable it will be 0. So in the first term the power it is 2, and in the second term the power it is 0. So for which the highest power of the variable amongst the term, otherwise two term means between the two term, it is our 2. So for which this polynomial having the degree it is 2. Another example I am showing here. In this example, the polynomial is 6x cube plus 8x plus 9. 6x cube plus 8x plus 9 it is given. So in the first term the power of the variable it is 3. Second term the power of the variable it is 1. And in the third term it is the constant term for which the variable it is 0. So one term 3, another term having the power it is 1, another one it is having the 0. So for which the highest power it is 3. So for which that one it is called as our degree of the polynomial. So degree of the polynomial, it means it is the highest power of the variable amongst the term. Clear? So now depending upon the degree, we will classify the polynomial. We will divide the polynomial it into different name according to their degree. Remember, linear polynomial. So here we will actually in our chapter we have already discussed in our last class that what is the definition of the linear polynomial. Remember the definition of the linear polynomial. A polynomial it is said to be linear polynomial if the power of its variable, if the highest power of the variable used it is equal to 1. If the highest power of the variable used it is 1, otherwise if the degree of the polynomial it is 1, then after that polynomial we can call it as the linear polynomial. Once again repeating, linear polynomial means the polynomial where the highest power of the variable used it is 1, then after that polynomial we can call it as the linear polynomial. Otherwise one can say the polynomial it is said to be linear polynomial whenever the degree of the polynomial it is 1. Ready? So few of the example I am showing. One it is 5x. So here the degree it is 1, 5x to the power 1. So for which is linear. Okay, one term for which it is linear. Then after x plus 6, here it is also two terms and the highest power it is 1. Another example it is our 6x plus 7. Another one it is our 3 by 2x plus 7. Is it okay to everyone? So in all these polynomials, the highest power of the variable it is our 1, for which all these polynomials we can call them as the linear polynomial. Then few of the example I am showing which are not the linear polynomial. How to check whether it is the linear, otherwise it is not the linear, and if it is not the linear, why it is not the linear polynomial. So one example I have shown at here. One it is our 2x square plus 3x. So this polynomial having the two terms. So in the first term the power of the variable it is 2. 2x square means 2. And in the another term the power of the variable it is 1. So for which here the highest power it is 2. For which we cannot call the polynomial it as the linear polynomial. Another example I have shown, and here it is the another polynomial it is 4x cube plus 7x plus 8. It has three terms. In the first term, the order it is power it is 3, and in the second term the power of the x it is 1, and in the third term the power of the x it is 0, as it is the constant term, and the highest power it is 3. As the highest power it is 3, it is at here, so for which we cannot call it as the linear polynomial. Otherwise here the degree it is 3. Highest power of the variable means a degree. As the variable it is 3, we cannot as the degree it is 3, so for which we cannot call the polynomial it as the linear polynomial. Ready? Then after quadratic polynomial, you just have to remember quadratic polynomial means a polynomial is said to be quadratic polynomial if the degree of the polynomial it is 2. Degree of the polynomial it is 2, otherwise if the highest power of the variable used in the polynomial it is equal to 2, also that polynomial we can call it as the quadratic polynomial. Another important thing I am saying, the term quadratic has come from the word quadrate. Quadratic has come from the word quadrate, which meaning is square. Which meaning is square. Understood? So here the degree should be 2. So few of the examples I have shown. One, it is 2x square plus 3x plus 7. Here the highest power of the variable it is 2. Okay. Another example, 2x square plus 6. Here also highest power of the variable it is 2. And another one, it is 2x square. Here the highest power it is 2. So it means in the 2x square degree it is 2. In 2x square plus 6, here the degree it is 2. And here it is 2x square plus 3x plus 7. Here it is also degree it is equal to 2. So for which all these three polynomials, we can call them as the quadratic polynomial. Okay. Next one, it is our cubic polynomial. Cubic polynomial, remember the polynomial where the degree of the polynomial it is 3. Cubic polynomial means the polynomial where the degree of the polynomial it is 3. One of the example is 5x cube plus 6x square. It has two terms. First term having the power of the variable it is 3. Second term having the power of the variable it is 2. So for which highest power of the variable amongst the term it is 3. So for which degree 3 means cubic. Another example, 6x cube plus 3 by 2. It has two terms. First term having the power of the variable it is 3. But second term having the power of the variable it is 0. So for which the polynomial having the degree it is 3 means highest power it is 3. So for which this one it is called as our cubic polynomial. Last one, another example, it is 7 by 2 x cube. 7 by 2 x cube, it is a polynomial of single term, and in the single term the variable used it is x and its power it is 3. As the highest power it is means single term means whatever the power it has 100% that power it is the highest one, otherwise greatest one. So here the power it is 3. So for which 7 by 2 x cube, it is a cubic polynomial. Okay, so today you just have to remember all these things. In the next class we will do the discussion how to find out the zero of a polynomial and also how to show the graphical representation of a polynomial. Thank you. Have a beautiful day.